Okay, we got two topics today. The first one is power in circuits. We did a pretty basic circuit with just one resistor and a battery, and we talked about the current, and we talked about your new best friend, Ohm's law, V equals IR, and we're going to be using that to figure out the power that is generated by a circuit. Why do we care about that? Well, that's really the whole point of a circuit, is to get some power out of it. So let's get started. The idea, you know this, power is P, it's energy over time. The unit for the power is the watt. 1 watt is 1 joule over second. This is a really quick derivation. Don't worry about it too much. The charge and the potential that it goes through, like the battery it goes through, that gets some energy. Again, energy over time is power. But we know that I equals Q over T, so if you look at it really carefully, you get that P equals IV. Okay, that bold equation is the first one you need to know. You may want to pause the video and record that in your notes. Power equals the current times the voltage. And we know, of course, V equals IR, that's Ohm's law. And if you substitute that in, you get, yep, wait for it, it's exciting, P equals I squared times R. And one more derivation, P equals IV, Let's rearrange that. I equals V over R. Substitute that in for I squared. Do some algebra. And you get P equals V squared over R. So I just threw a bunch of equations at you. Go ahead and pause. Write those 3 equations down. And literally all you're going to do is use them to plug and chug. It's just not that exciting. Sorry. Okay, so along those lines, I'd like you to do problem 70 and 71A and B from your packet that we've been working with. You know, the part 3 of the electricity practice problems. Pause, do 70, 71A, 71B, come back for the answers. And here they are. Okay, so how did I get those? I'm going to fly through this. If you think it's too fast, just pause and listen to it again. That's the beauty of a video. All right, so to find 70, they give you the R and the I, and we're just going to use P equals I squared times R. Plug it in, get 14 watts. For 71A, what's really cool, and this is true on your devices, you pick up any device that you plug into a wall, it might be hard to see, but it will tell you the power and the voltage. Just like this, it might be marked 750 watts, 110 volts. So what does that tell you? That's telling you the power of the voltage, and we're looking for the current. So I equals P over V, and I got 6.8 amps. And then part B, how do you find the resistor? I used P equals V squared over R. Solve for R. You get R equals V squared over P. And that gives you 16 ohms. I know that was fast. If you got it right, you're good to go. Keep going. If you didn't get it right, listen again, pause, write stuff down as I say it. Okay, wasn't that exciting? This is one of my favorite topics. I'm really sorry not to be with you guys when we talk about it because I think it's so cool. All right, so series circuits. We talked about circuits being your coach yelling at you and saying, do some push-ups, do some burpees, etc., etc. Well, if it's a series circuit, you're going to do it in order. Just like if you read a series of books like Harry Potter, you read them in order. If you're watching a series on TV, you tend to watch it in order. Okay, so that's what we've got. What we're going to be doing is we're going to be looking for something called the equivalent resistance, or the REQ, as an abbreviation, and this is what the circuit looks like. So this is 3 resistors. It could have 1, it could have 2, it could have 4, whatever. Let's just focus on 3 right now. And you can see there's a battery right here, and that battery is supplying voltage to the entire circuit, and this is the current. And the idea is that the same current goes through each of these resistors. Why? Well, if you think of an electron goes through, it has no choice. It has to go through this resistor, and it has to go through this one, and it has to go through this one and come back. So one of the analogies I like to use is if you pretend that you are all dancing in a circle. Israelis actually do this a lot, and Jews do it a lot too. So if you hold hands with a group of people and dance in a circle, and you do sort of, the grapevine, going around in a circle, da 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 da, etc., right? Everybody has to go the same speed. You can't have someone dancing really fast and someone going really slowly because you're all holding hands. So you're all connected, so everybody's got to go the same speed. That's exactly what's going on with the electrons. They are all going around in a circle, and they all have to go the same speed. And that speed really is the current, right? Because the current is the rate of flow of charge. So the current that leaves the battery is the same current that goes through resistor 1, the same current that goes through resistor 2, and the same current that goes through resistor 3. Okay, so that's my analogy for the current. And there you go. There's a summary of it. Now, what to do about the voltage? Well, we talk about the voltage as being something that you measure across a resistor, and you're going to see a tool for it in just a second. So we've got V1 is the voltage across R1, V2 is the voltage across R2, V3 is the voltage across R3. And here's my analogy. It's very much a pretend story. Pretend all of us get on a bus and we go to Tyson's, and each of you, as you get off the bus, I give you $100. And I tell you, you must go to these 3 stores at Tyson's. I don't know, Old Navy, you got to buy a coffee, you got to go to Starbucks, and let's go, you go to Nordstrom. Okay, so you're going to spend, and my rule is you have to spend all your money at these 3 stores, and you're going to come back and get back on the bus, and I will give you $100 more, and we'll do it again. Please remember, this is an imaginary story. So I give you $100. Let's say you go to Old Navy first. Maybe you spend 20 bucks there. You go to Starbucks. Maybe you spend 10 bucks there. And then you're going to spend your remaining 70 at Nordstrom. Come back, get $100, do it again and again. The amount you spend, in my analogy, is the voltage. So you're given, let's say, 100 volts, and maybe you spend 20 volts here, and 10 volts here, and 70 volts here. And you come back, you run out of volts, and you come back and get some more volts. If another physics teacher heard me telling this story, they'd be really upset. This is not the way we talk about voltage, but I think it's an okay way for you to think about it. The other thing is that you have to go through all 3 stores. The electrons have to go through all 3 resistors. Okay? So the way we talk about it, we might talk about voltage drop or just voltage across. The language changes a little bit, be a little bit flexible with that. But V1 is the voltage drop across R1, etc., etc. And the idea is, remember I told you Ohm's law is a great law? Well, it holds here as well. So V1 equals I1 times R1. And V2 equals I times R2. And the reason I don't have the little subscripts on for I1, I2, and I3 is the current is the same for all of them. So I equals I1 equals I2 equals I3. And the voltage, if you add it all together, adds up. So V total equals V1 plus V2 V plus V3, just like we did with the money, right? I said $20 plus $10 plus $70 equals 100. And this helps us find the REQ, and I could actually derive it for you, but I'm not going to. The equivalent resistance, we say, is the total. You just take the R1 plus the R2 plus the R3. Okay, so, oh, and of course, right, Ohm's law comes back at you. V total equals I total REQ. So, I'm going to also throw these equations at you as well. By the way, you need to be taking notes. Probably should have told you that before. Stop the video, write down all those equations I just gave you. Write down these as well. They're not that exciting. It just talks about the P total and for the individual P's. Okay? Again, that's not the, I mean, it's fine. It's just not that exciting. I set up using FET, and you may want to do this too, but I did this for those of you who can't access FET at home. What I did is I put in 2 resistors. I put in a 10 ohm and a 15 ohm and a 9-volt battery. I put in an ammeter so that the current runs through this. And this is a voltmeter. This is measuring the voltage across this first 10 ohm resistor. So pause this, take a look at the math, see if the math works out. You should get that the REQ is the sum of these two, is 25. If you know the REQ and you know the V total, you should be able to figure out the I total, and that's 0.36 amps. And again, that's the I that runs through the whole circuit, so it runs through the 10 and it runs through the 15. And then if you just look at V equals IR, you would find out that 10 times that 0.36 equals 3.6 volts. So check it out, it works. And so I really recommend, if you can, go to FET, set this up, play it out, see if I've lied to you. It could be, you never know, so you really should verify for yourself. But here are some more pictures I took. So I moved the voltmeter over here. I took the voltage across the second resistor. Again, it's still 0.36 amps, so 0.36 times 15 should give you about 5.4. And then this is the total. So you can see it's embracing both resistors. It's enclosing both resistors. And so the total resistance is 25. This should give you the total voltage. And if you round up 8.999, you would get 9. Isn't that cool? So, especially if you are at home and if you still have power and you have nothing to do, please, please, please play with the FET simulation. See what you can figure out. Okay, here's your chance. You're now going to try these problems, 76 A through G and 78 A through D. Please pause the video, and I will come back to you with the answers. Pause now. Okay, welcome back. Here are the answers, and I'm going to fly through these with the intent that if you get stuck, you're going to pause and listen to me again. Okay, the equivalent resistance. The way I did that is I added up the two resistances of 10 and 5, and I got 15. How did I get the I total, which is what B is asking for? I just take V total divided by REQ. 12 divided by 15, I get 0.8 amps. And I didn't write this down, so listen to this equation and write it down in your notes. I total equals I1 equals I2 equals I3. So the current flowing through each resistor is also going to be 0.8 amps because it is the same. Hopefully that makes sense. And then I looked at the voltage across the 10, and I just did V equals IR. So 0.8 times 10 equals 8. And again, across the 4 ohm resistor, V equals IR. So V equals 0.8 times 5, and you get 4 volts. And check it out. You didn't have to do this, but you should notice that 8 plus 4 equals your V total, which is 12. It's magic. It's awesome. It works. All right, then you're going to find the, this is looking for P total in part F. And I just did V total squared over REQ, and I got 9.6 watts. And for part G, I did P equals I squared R, and I did 0.8 squared times 10 equals 6.4 watts. All right, that was fun. Let's do 78. 78 has 3 resistors rather than 2, and the equivalent resistance, you just add them up, you get 126 ohms. For part B, I did I total equals V total over REQ. 12 over 126 is 0.095 amps. For part C, again, I total equals I1 equals I2 equals I3. So it's going to be the same current for all of them. I just didn't type it out 3 times. And then part D, I did V equals IR for each of them. Okay, same I. This is your I, the different R's, and I got those values. And then for part E, that's looking for P total. So I did P total equals V total squared over REQ, and I got that number. And for part F, I just looked at it for the 10 ohm resistor, so P equals I squared R, and I got 0.090 watts. You should notice that this is a very small amount of power, right? We're used to 70 watt bulbs, 100 watt bulbs, etc. This is equivalent, right? Same sort of wattage, same thing. It's very, very small, so it would not be generating a lot of power, and we'll talk about that next time. Okay, I know that was fast. I was trying to jam it into under 15 minutes. Pay attention to what is due on Monday. I really hope I see you on Monday. Otherwise, I will be making another video, power permitting. Okay, have a good snow day.